Every day I've been saying this. How do you know when you look at a test problem or quiz that it's case 1? Well, I've been saying this every day.
2 angles on a side.
2 angles on a side, you just set up your proportions and get your answers and you're done, right? Those were pretty easy. You got to write the proportion though, and your calculator will do everything. Okay, look at number 21. See the answer sheet there? There's the proportion to find angle B, 20.6. Add the 2, subtract from 180. There's angle C, and then there's the proportion to find side C. You want to just check to see if you're getting them right. There's 21. 22 is not on your iPad, but look, here's the answers. There's the answers to 22. You can just check there. There's the answers to 22. 23, look on your iPad. If you get a problem tomorrow, like 23, you have to write that, but you see it's no triangle there, right? Because it's out of the range. But you got to have that written down. I mean, there's the proportion for 23. Sine of C is 1.7632. Make sure you write down the 4-digit decimal, but then because that's out of the range, it's no triangle. So that would be kind of a fast problem. Okay, swipe to the next page. And there's 28 up at the top. There's angle B, 30.4, angle A, 60.9. There's your proportion for side A. Now, something else that I need to point out. Swipe to the 3rd page, fellas. Okay, now I want you to look at these 2 problems there. You already did these a few days ago. Look at 19 and 27. How do you know if it's case 2? Somebody? How do you know if it's case 2? Remember, ambiguous case. How do you know? How?
It's 2-sided in an angle, and the angle is opposite one of the sides.
Okay, which is true in 19 and 27. But remember the study sheet? You have that. It had all that written out. When the angle's bigger than 90, like both of those are, see 19 and 27? How do you know if you have a triangle or not? Here, how about this? How do you know if it's no triangle when the angle is obtuse? What are the 2 sides you always have to compare? Joe?
Opposite and adjacent.
Okay, now look at 19. Isn't the opposite side bigger than the adjacent? Look on my answer sheet there. So you got a triangle, you go ahead and use your law of sines just like you always do. In number 27, isn't the opposite bigger than the adjacent? Yes, so you go ahead and do your law of sines and get your answers. If the opposite was smaller, you would say no triangle, and you would have to tell me why. Because the opposite is smaller than the adjacent. Which leads me to the last thing. Swipe to the next page. You know, I did this for 2 days. This would be worth the most points on a test. Look at 18. There's the one from 325. The figure, in fact, I will tell you this right now. When you take the quiz tomorrow, I'll have that drawn right on the paper. Everybody. What I'm trying to say is you're going to know which one's the 2 triangle problem. I mean, you'll know. And when I pass the quiz, I'll tell you, number, whatever, is a 2 triangle. I'll have that drawn like that, and that'll be marked A. Because the angle I'm going to give you is going to be A. Now, are you all clear how you mark everything else now? You got to have it all marked. That's B sub 1. Well, then we have that. This is side A. This is side B. What's that? Oh, come on. For 2 days I've been doing this now. What's that angle going to be marked? Max?
B sub 2.
Capital B sub 2. There's small c sub 2. There's small c sub 1. Okay, look on my answer sheet. I got everything there. I did A over sine of A equals B over sine of B. I found B sub 1. I caution you here. I mean, there's a lot of things to find. Do you all realize you get angle B sub 1 wrong, all them other angles are going to be wrong. So please, when you set up that proportion like I have there, where it says angle B sub 1 is 74.6, you want to make sure you're doing that correctly. And then remember, whatever this is, that's the same, and then you just subtract from 180, you get B sub 2, right? Then you just go 180, subtract angle A and B sub 1, it'll give you big C sub 1. And then 180, subtract angle A and B sub 2, gives you capital C sub 2. Now, let me ask you, how many of you got 18 correct? How many got it right? See all the values there? And then swipe one more page. There's the other one I assigned, 25. Look at the figure. The figure's the same. Does anyone need to ask me something about two triangles? I'm only going to give you one on the quiz. So do you understand what's going on in this quiz then? It's just case 1 and case 2. Yep.
If the one of the givens is in degrees and minutes, do you have to change all the answers?
Here, I'll make that a lot easier for you right now too. None of the angles I'm giving to you are in minutes. They're all in decimal degrees. Don't even have to worry about that. Okay? That actually makes one less thing you got to worry about. All the angles I give you on this quiz will all be decimal degrees. They won't be in minutes, so don't even worry about that. Does anyone have a question? That'll be tomorrow. Okay, now, go to a new page in your notebook. This quiz should not be that difficult, fellas. You just need to write the proportions. Your calculator's going to do everything else. All right, this is what I want to do right now. Go in your notebook. No, keep it. The quiz is tomorrow. I don't want to take your papers. That's stuff like you need to look for the quiz. Okay, you need to write that down. You don't need anything with your iPad right now. You need to write down what I just put up there. I think you can see that okay. Case 3. Given two sides and the angle included between the two sides. Now that's different. All right? Case 2 was two sides and an angle opposite one of the sides. This is SAS. Side, angle between the other side. All right, you know what? Here, you might as well, we're not going to do it today, but you might as well write that down too. That'll be next week. That'll come next Monday. But you might as well mark it down. There's 4 cases altogether. The quiz tomorrow is on case 1 and case 2. I'm going to show you case 3 right now. It's not that bad. It's a new formula, but it ain't that bad. And then case 4 I'll show you on Monday. Okay, here's what you need. So in your notebook, you want to write down this. I will give you this when it comes time to take the test. You don't have to memorize this. This is called the law of cosines. Now watch this. You don't write that down. You're not going to learn it like that. I'm going to translate all those words. Just give you this. Now look what this says here. Yeah, let's see here. It's a little bit more involved. Watch this. the square of a side of a triangle is equal to the sum of the squares of the other two sides minus twice the product of those two sides and the cosine of the angle included between them. I read that fast on purpose, and I know you're going, what the hell is that? It sounded very confusing. I did that fast on purpose. Here's the translation of the law of cosines. There's 3 different forms, because it depends on what sides they give you. The square of a side is equal to the sum of the squares of the other two. Let's just do that much. Now, in your notebook, the square of a side is equal to the sum of the squares of the other two sides. Now, you guys, you need to write this down. This is what it looks like. The square of a side is equal to the sum of the squares of the other two sides minus twice the product of these two sides times the cosine of the angle included between them. Now watch this. The square of a side is the sum of the squares of the other two sides minus twice the product of those two sides. Look, minus twice the product of those two sides and the cosine of the angle included between. Now what would be the angle between side B and side C? What would be the angle included, if this was B and C, what would be the angle included between side B and side C? Andrew, it'd be A. Minus twice the product of these two sides and the cosine of the angle included between them. Now mark this down. You do not have to memorize that. You know, when I give you something like people says, we gotta learn that, you don't. I give it to you. I just want you to be able to use it. Okay, well, let's say you were given 2 different sides. B squared would equal, now watch what I'm going to do. The sum of the squares of the other two sides, look what I'm doing, minus twice the product of those two sides times the cosine of the angle included. What's the angle that's going to be between side A and side C? It's going to be capital B, right? There's another form. All right, C squared equals the sum of the squares of the other two sides minus twice the product of those two sides times the cosine of the angle included between them. Now all them words up there, forget it. All them words translate to this. Do you understand? I mean, look, we just did it. We just translated them into 3 formulas. There's 3 forms for the law of cosines. So, fellas, this is all you have to do. There you go. Example 1. Mark that down. Now watch this. Have your calculators out. This isn't bad at all. Have your calculator out. The first thing you're going to do is find the third side. And I'm going to give you all this real plain. Joe, pay attention. I'm going to give you this all plain. First, find the third side. So obviously, I'm going to find side A first. So you're going to use this one. Do you see how you know which one to use? This is what you use when you want to find side A. Side B, use this one. Side C, use this one. And remember, you will have all those on a test. Now, this is how you have to do this. A squared equals. Now, we're going to plug into this. Now, you do what I'm going to do in your notebook, because this is what I need to see. A squared is B squared plus C squared. Look how I'm going to do this. B squared, look what I'm doing, plus C squared. All I did is plug those in. Now put it in your notebook the way I'm doing it. Minus 2 times those two sides. Minus 2 times B times C times the cosine of the angle included is given to you. There it is, capital A. It's 42.3. Now everybody write this down, because here's the whole key today. Using your calculator correctly. Now everybody get your calculator out here. Here's what you have to show me. You're going to take all of that right there and punch all of it into your calculator. And what I want to know what that decimal number is going to be. Now, everybody, you all got different calculators. Now, you got to make sure you're doing this correctly. You're going to enter in 12.9, and then you should have a square button on there, squared, plus 15.4, square that, and then hit equals, So far, well here, somebody, so far what number's in your display? Are you doing what I said? You're going to punch in 12.9, hit the square key, plus 15.4, hit the square key, then hit the equal sign. Can one of you tell me what's in your display with just that so far? Because you got to make sure you're all getting the right number here. Alex.
403.57.
Okay, 403.57. That's what should be in there so far. Now, look what you're going to do. Minus 2 times 12.9 times 15.4 times the cosine of 42.3 degrees. Then hit the equals button. And I would like to hear what that number is. You guys, this has to be written down, and you got to make sure you're all getting this number. Did you do it? Take this squared plus this squared. You're just punching all this in. Minus 2 times this times the cosine of 42.3 degrees. You all should have the same number in your display. Somebody? You didn't do it? You all should have a number there. It's the number for all of that you just punched in. What's the matter? You don't like what you're seeing? What'd you get? We got to make sure we're doing this right. Adam.
109.7.
109. Okay, now listen to me. Listen to me. Don't wipe out what's there. Do you have 109 point a bunch of numbers? But you guys have to figure out what you're doing wrong. See, you all have different calculators. You're the one that's got to know your keystrokes. Because my calculator is just a basic scientific calculator. A lot of you have the fancier ones. You got to know how to operate them. It's 100, I'm going to read what's on mine, 109.69977, but I'm not going to wipe that out. 109 point, let's go 4-digit decimal. What would be the 4 digits here after the 109 if I go 4-digit decimal? Well, you know what? Let's just go 2. Well, don't wipe your calculator out. What would be the 2 after the decimal point there? Jack?
70.
Okay, because it's 0.699, so... Guys, you have to pay attention to me. You see that line of work right there? It must be written on your paper. It must be written on your paper. I have to see that number that comes out of all that. And then all you got to do to get side A then is what? On your calculator. This part's easy. All you got to do to get side A then is what? Oh my God, come on, this keystroke's easy. Joe?
The inverse cosine?
No. There's no cosine here. This is A squared equals a number. Square root key, right? Hit the square root key. Round to the nearest 10th. What do you got? Ethan? 10.5. Now, let me step back. We're not done yet. Who has a question? So you're going to find the third side. Now, what if they gave you just A and B? If they gave you side A and B, you'd be plugging into this one first. Do you understand? If they gave you A and C, you'd be plugging into this one first. But do you see this line of work? I want to see all that. Then after that, punch away. The calculator will do everything. And then there's A. There's the first step. Second, find the smaller of the remaining angles. Now, this is big, you guys. Find the smaller of the remaining angles. Find the smaller of the remaining angles. Find the smaller of the remaining angles. This is just going to be your proportion, just like you've been doing. How do you know which angle is the smaller of the remaining angles? Not a hard question. Look at the givens. Which angle is the smaller angle of the remaining angles? It's not a hard question. Rob? B. Why? Because side B is smaller than side C. Find the smaller one. So how are you going to find angle B? This is just your regular proportion. But we've been doing this since last week. Somebody? Set up a proportion. Ethan.
You put A over cosine 42.3.
Whoa. Did you hear that? Just using that as an example. It's not cosine. This is your normal law sines now, Ethan.
Oh, so we just use regular sine, even though it's the cosine?
No, you just use the proportions, just the law of sines. That's what you've been doing.
Okay,
So A
over the sine of 42.3.
So A is 10.5 over the sine of what? 42.3?
Yeah.
And now which angle did I say we're finding?
B.
That's right. So B is 12.9 over the sine of capital B. Who has a question here? I mean, this is very straightforward. Then, with your calculator, now you've been doing this since last week. I need the 4-digit decimal here. This times this divided by that, right? Just like you've been doing. 42.3 sine times 12.9 equals divided by 10.5. What do you got? 4-digit decimal. Got to be written down on the paper. What's the 4-digit decimal there? David. 0.8268. Got to be written down. This has to be written down. And then you just go inverse sine button, right? Inverse sine. What is it? Round it. Nearest 10. Jack?
55.8.
55.8 degrees. And then it's pretty simple to finish, isn't it? What's the only thing left to find? Howard.
Angle C.
And that's just add the 2 and subtract the 180, right? There's A, there's B. So just take 180, subtract 42.3, subtract 55.8. What is it? Howard.
81.9.
All right, now let's recap. I'm just giving you 4 problems here. Question first.
Yeah, why do you have to find the smaller?
I'll tell you why. I was waiting for the question. You said, why do you have to find the small? Because one of these angles could be greater than 90 degrees. It's possible one of the angles could have been an obtuse angle. What I'm saying is, on your calculator, you probably wouldn't see that unless you were smart enough to know this angle is bigger than 90. It's in the second quadrant. So if you always find the smaller one first, there's no chance it could be greater than 90. That's why you want to find the smaller one first. Then you avoid all that confusion. Now, go to your textbook right now. Go to your textbook right now. Go to page 299. Page 299. Now, do you see the work? Plug in, show this and that, and take the square root, and find the smaller one using your proportion, then add the 2 and subtract from 180, and you're done. 4 problems. Go to page 299. 13, 19, 20, and 33. Now everybody go there. Take out a good sheet of paper. Everybody go to page 299. I want you to see this in your book. Go to page 299. Okay, now look at 13. Look at 13. Okay, are you there? You just need to see this. Look at 13. They drew it for you. You see the 2 sides in the included angle? So what's the 4? What side is that? The 4. It's marked there, but tell me. Yeah, that's small b. The 6 is small c, and then there's the 61, the included angle in between. So when you do number 13, which one of these are you going to plug into first? Howard?
A squared.
The first one. Look at number 19. Do you all, look, you can, when the test comes, do you all understand that's case 3 by looking at it? You need to understand this. If they give you side B and C, the angle between them would be A. It's case 3. That's law of cosines. Number 20, same thing. Number 33, same thing. Yes?
Is case 2 the only one that matters if the angle is obtuse or acute?
Yes. Now, I'm glad you asked that question because look at number 33. Everyone, look at 33. Look at the angle there. It's 112.8. So when you do 33, the end of your number 33 would have that, right? But guess what? Can one of you tell me what kind of an answer that'll be for the cosine of 112.8? Quadrants, fellas, quadrants. What kind of an answer will the cosine of 100? Your calculator will do it for you, but what kind of an answer will the cosine of 112.8 be? It'd be a negative answer, wouldn't it? Right? Second quadrant, cosine of something is negative. But what you're asking me is you won't have to worry about that because when you're entering it in your calculator knows that. It'll make it negative right away. So it's not something you have to figure out.
So why does that matter? If it's negative, is it possible?
Well, if this turns out to be negative, this -2 times that would make this plus that in your calculator when you're calculating it. So it would matter because it's going to change your number. Okay? Does anyone have a question? That's all there is to case 3. 2 sides, included angle. So tomorrow you got a 40-point quiz on case 1 and case 2. Monday,